Let's begin by discussing why understanding dependencies is crucial when automating API testing. In the context of API testing, dependencies refer to the various connections and relationships between APIs, as well as the role of detailed API documentation. These elements form the foundation of our testing strategy, ensuring that the automated tests we create are not only reliable, but also accurately reflect real-world usage scenarios. Without a solid understanding of these dependencies, it's easy to miss critical interactions, which could lead to overlooked issues or test failures. By taking the time to fully understand these dependencies, we set ourselves up for success in API test automation. Understanding API connections is one of the most critical aspects of automating API tests. APIs rarely exist in isolation. They usually interact with other APIs or services, forming a web of dependencies. By understanding these connections, we gain insights into the business logic that can be tested automatically. This knowledge allows us to create test cases that accurately reflect the way these APIs interact in real-world scenarios, ensuring that our tests are comprehensive. For instance, if one API relies on the output of another, our tests need to validate that this interaction occurs correctly under various conditions. This understanding is what allows us to catch issues that could potentially disrupt these interactions in a live environment. API documentation is a critical resource for anyone involved in automating API tests. This documentation provides all the necessary details, such as parameters, headers, and the various types of request-response objects that we need to create accurate and effective tests. It essentially serves as a blueprint for understanding how the API is supposed to work, which is crucial when designing tests that need to verify correct functionality. Without thorough API documentation, the risk of missing important details or misinterpreting how an API should behave is significantly higher. This could lead to tests that don't fully cover the required scenarios, potentially allowing defects to slip through the cracks. Therefore, having access to and utilizing comprehensive API documentation is a key part of a successful test automation strategy. Automated API testing can be integrated into the development process by either developers or test automation engineers, TAEs. With the shift-left approach becoming more prevalent, it's increasingly recommended to distribute testing responsibilities across different stages of development. This means conducting tests at the component integration level as well as system integration level. By catching issues early through this layered approach, we can prevent defects from escalating as the software progresses through the development lifecycle. Furthermore, by integrating automated tests into continuous integration and continuous deployment (CI/CD) pipelines, we ensure that our APIs are tested continuously as part of every build and deployment. This approach not only improves the quality of the software, but also speeds up the development process by identifying and resolving issues as they arise. One of the most powerful tools we have in API testing is contract testing. Contract testing is a specific type of integration testing that ensures different services can communicate effectively and that the data shared between them is consistent with a defined set of rules. This method goes beyond simple schema validation. It involves both parties, the provider and the consumer, agreeing on a contract that outlines the expected interactions between their services. By capturing these interactions and storing them in a contract, we can continuously verify that both parties adhere to the agreed standards. Contract testing is particularly useful in microservices architectures, where multiple independent services need to work together seamlessly. One of the biggest advantages of contract testing is that it allows us to detect issues much earlier in the development process, often before they even reach the production environment. This early detection is crucial for maintaining the stability and reliability of the entire system. There are two main approaches to contract testing: consumer-driven and provider-driven. In the consumer-driven approach, the consumer sets the expectations, specifying how the provider should respond to requests. This approach ensures that the provider's services meet the specific needs of the consumer, which is particularly important when the consumer is dependent on the provider for critical functionality. On the other hand, in the provider-driven approach, the provider creates the contract, outlining how its services operate. This approach is useful for setting clear expectations for all consumers, ensuring that they understand the limitations and capabilities of the provider's services. Both approaches have their benefits, and the choice between them often depends on the specific context and requirements of the systems involved. Contract testing offers several significant benefits that make it an invaluable part of an API testing strategy. One of the most important advantages is the early detection of defects in the software development lifecycle, SDLC. By validating that services are communicating correctly according to the contract, we can catch issues early before they escalate into bigger problems later in the process. Additionally, contract testing makes it easier to identify the source of defects. Since the contract clearly defines the expected interactions, it becomes straightforward to pinpoint where things are going wrong when a test fails. This clarity helps reduce the time spent on debugging and ensures that issues are resolved more quickly. Overall, contract testing not only improves the quality of the software, but also enhances the efficiency of the development process. In conclusion, understanding the dependencies involved in API test automation is critical for building a successful testing strategy. By gaining a thorough understanding of API connections, utilizing detailed API documentation, and implementing best practices like contract testing, we can create a robust framework for automated API testing. This approach ensures that our tests are comprehensive, reliable, and capable of catching issues early in the development process. Ultimately, this leads to higher quality software and a more efficient development process, which benefits both the development team and the end users.